Hi, today let's see how to search in a linked list through iterative and recursive approaches. Now let's first understand about the iterative approach. Suppose we have this linked list, say 1, 2, 3, 4, 5 and null. And we are given suppose key is equals to 3. Our goal is to check whether this key exists anywhere in the list or not. So we start the traversal from the head of the linked list, that is here. So we create a pointer called current and initially it points to the head node. Now we compare the current node's data with the key. So right now current dot data is 1 because the data in the first node is 1 and 1 is not equals to 3, so we move to the next node. Now current is pointing to this node. Now current dot data is 2. 2 is not equals to 3, so we move to the next node. Now current dot data is 3. Here the current node's data matches the key. That means the key is present in the linked list, so we immediately return true. One another case to keep in mind is suppose we reach null, it means we have checked all the nodes, so the key was never really found. So in that case, we return false. The logic is very simple. So the first step is to start from the head, and the second step is to compare current node with the key. Third is to move forward. 4 is to stop when the key is found or the list ends. Now that we have clearly seen how the pointer moves, let's convert this exact flow into code. So I have this function that takes two inputs, the head of the linked list and the key we want to search for. Now let us first initialize the traversal pointer. So current is head. We created a pointer called current and initialized it with the head node. So this pointer will help us traverse through the list. Now while current is not none, so we now traverse the linked list using a while loop. This loop will run until we reach the end of the list, which is null. The next step is to compare the current node with the key. So if current dot data is equals to key, we return true. So at each node we compare the current node's data with the key. If they are equal, we immediately return true because the key is found. Now we gotta move to the next node. So current equals to current dot next. Okay, so if the key does not match, we move the pointer to the next node, and if we exit the loop, it means we have reached the end of the linked list and the key was not found, so we return false. All right, so now let's run the code. So as we can see, since we have the key present, we are printing true. So this iterative approach searches the linked list in linear time using constant space, making it a preferred approach in interviews. Alright, now let's quickly look into the recursive approach. So let's take the same linked list, say 1, 2, 3, 4, 5 and null. So in recursion, we don't manually move a pointer. Each function call handles one node and the remaining list is handled by the next recursive call. So the first recursive call starts at the head node. So let's say we have search 1. So we compare 1 with 3. Since they are not equal, we search to the next node. So we have search of 2. So since they are not equal, we proceed to the next one and we go to third one. Just understand this, think of this as a stack. Each call waits for the result of the next one. So now we have search of 3. At this point, the current node's data matches the key, so this function call immediately returns true. So this becomes true, this becomes true as well, and this becomes true as well. So once true is written, every previous recursive call also returns true, and the final result also becomes true. And suppose if key is not present, recursion keeps moving forward until the head becomes null, and this is our base case and we return false. Now that we understand how recursive calls move through the list, let's code this logic. So this is a function that I defined which will recursively search for the key in the linked list. It takes the current node and the key as the input. So let's tackle the end of the list base case now. If head is none, we return false. So if head becomes null, it means that we have reached the end of the linked list and the key is not present, so we return false. Now let's check the current node. If head.data is equals to key, then we return true. So if data stored in this node matches the key, we immediately return true. Now let's make the recursive call for the remaining list. So return search key of head.next of then key. So if the key is not found in the current node, we recursively search in the remaining list by passing it to the next node. Now let's look at the output. So as we can see, it returns true as it found the key node. Now coming to the time complexities, earlier when we discussed about the iterative approach, the time complexity is big O of n in the worst case because we traverse all nodes once, and the space complexity of it will be big O of 1. We only use a single pointer current, so no extra memory is used there. And coming to the recursive approach, time complexity will be big O of n. So recursion still checks each and every node once. And the space complexity will be big O of n due to the recursion call stack. So each recursive call stays in the memory until the base case is reached. So in the interviews, the iterative approach is preferred because it is more space efficient and avoids recursion overhead. The recursive approach is mainly used for understanding the problem or when the code needs to be very expressive. So if you're asked to implement search in a linked list, go with the iterative approach by default and just mention the recursive approach as an alternative. Comment down your thoughts below. Thanks for watching.